Here's another conversion problem, kind of disguised as a problem with some interesting facts about shrimp. Peacock mantis shrimp feed largely on snails. They shatter the shells of their prey by delivering a sharp blow with their front legs, which have been observed to reach a peak speed of 23 meters per second. So that's a speed. What is this speed in kilometers per hour? So we're just being asked to make a conversion here between a speed of 23 meters per second and find it in kilometers per hour. Well, so what that means is, of course, make a fence post and start listing information that we have and come up with information that we need. And we know we've been given speed in meters per second and we're asked to find speed in kilometers per hour. So somewhere out here at the end, we want kilometers per hour. And we've been given 23 meters per second. And this horizontal part of the fence here, I don't know what you call that part of the fence, but that is also like the fraction bar. So it could be pronounced per, so meters per second, this piece here. So I'll go ahead and start building my fence posts here. Remember that each fence post has to be a fraction equal to 1 whose denominator cancels with the numerator of the fraction just to its left. So I'm going to start now by looking for a fraction equivalent to 1 that has meters in the bottom. So I am going to write meters, and knowing that I'm going towards kilometers, I'm going to choose the factor that equates 1,000 meters to 1 kilometer. And since meters cancels in the denominator here with the numerator here, I'll just go ahead and cancel that now. So I'm now, if I stopped and did the problem right now, I'd have kilometers per second, but I want kilometers per hour. So let's look for another fence post, and this time, of course, it has to be equal to 1, fraction equal to 1. In the denominator, I need something that is going to allow me to keep kilometers, but I need something in the numerator that will cancel with seconds. So I'm going to go for a way to convert between seconds and hours, and I'll put the seconds in the numerator. And that's because I want to be able to cancel seconds in the denominator over here with seconds in the numerator here. So what I'm going to use is the fact that 3,600 seconds is equivalent to 1 hour. So now what I have is the ability to cancel this seconds with that seconds, and if I circle what's left, I have kilometers in the numerator and hours in the denominator, and that's what I want in my answer. So I'm done converting as soon as I have nothing left but the units that I want to express my answer in. And now technically I'm ready to start multiplying and dividing. So let's have a look at this. In the numerator, I end up with 23 times 3,600, and in the denominator, 1,000. Now I could go ahead and type that into my calculator right like that, but if I notice that there are zeros that I can cancel here, and really I'm dividing both numerator and denominator, I'm dividing out a common factor of 100, I'm left with 23 times 36 divided by 10. Which ends up being just a little bit quicker to put into my calculator. So 23 times 36 divided by 10 is equal to 8.28, and our calculator says E1. So what that means is, of course, 8.28 times 10 to the first. But before we go and just write this down as an answer, let's just observe that we've got 2 significant digits and 4 significant digits. Well, we've been given 2 in the problem. So we need to round this to 2 significant digits, 2 sig digs. And so what that means is we'll express our answer rounded to 2, so 8.3 rounded to 2 digits times 10 to the first, and then our units were kilometers per hour. So if we go and write this as a proper therefore statement, therefore the shrimp's legs move at peak speed of 8.3 times 10 to the first, which is 83 kilometers per hour. And there it is.